In chapter 5, okay, we're going to deal with the intersection between lines and planes. So the first concept that I need you to understand is the keyword here is intersection. When we talk about two lines in your secondary school, for example, y equals 3x plus 1 versus y equals minus 7 plus 8. If I ask you for the intersection between these two lines, what will you do in your secondary school? You equate the two lines together. Okay, when you equate the two lines together, that will produce your point of intersection. So in this topic, okay, in this chapter, we're going to deal with the relationship between two lines, the relationship between line and a plane, and the relationship between two planes. Okay, so if I were to tell you, okay, in the terms of vectors concept, this is how your vector equation of a line look like. So if I ask you, find for me the intersection of the two lines, what will you do? So same thing, just like how you handle this, I'm going to equate both your equation of the lines together. Okay, so we're going to consider a few possibilities first. So if, first case, the two lines were to intersect, okay, in vectors, if two lines were to intersect, they 100% surely will only intersect at a point. So I say again, if two lines were to intersect, they will definitely intersect at a point. Okay, so look at this question now. Example 1a. I ask you to show that L1 and L2 intersect. Okay, show for me L1 and L2 intersect. So I have these two lines. Okay, these two lines given in the question. Your job is to show. So I cannot say that they intersect. So that it's important that I write down the word consider. Consider this, okay, is equals to this, okay, which is what's happening here. Then what happened next is I want you to look across horizontally. Look across horizontally, look across horizontally, and look across horizontally. And if you look across, I can generate three separate equations. And in these three separate equations, I have two unknowns, lambda and mu. Okay, so what I need you to do is to solve any two equations. So for lecture purposes, I am solving equation 1 and 2. I solve equation 1 and 2, and I get mu, and I get lambda. From here, I am going to substitute this mu value, this lambda value into equation 3. And then I check the left hand side as well as the right hand side. If they are consistent, what does it mean is that when mu equals to 1 and lambda is equal to minus 2, it satisfies equation 1, 2, and 3 at the same time. And so I have a point of intersection. And so what is this point of intersection? All I need to do is to substitute the lambda value either into this equation or the mu value into this equation. And then I can get my point of intersection of the two lines. Okay, let's look at example B now. This time around, I ask you to find the position vector of the points of intersection. Okay, so when the question is set this way, I already tell you that the two lines intersect. Agree? So all I need to do now is same thing. Consider the two lines, put them together, and same thing. I am just going to generate the three equations with your two unknowns, and same thing. I'm going to solve equation 1 and 2. But this time around, I don't have to check because I already tell you that they intersect. So all I need to do is to find a mu value or to find a lambda value, pump it back into original equation. I can actually find the point of intersection of the two planes. Okay, however, okay, I need to warn you, double check your answers. So usually, even if it's a fine question, it doesn't take you very long to actually verify that the mu value or the lambda value satisfy all three equations. Okay, so if two lines were to intersect, they will definitely intersect at a point. So what if the two lines don't intersect? Okay, so if two lines don't intersect, one possibility is that they must be parallel lines. If they are parallel lines, common sense will tell you they will never intersect. Okay, Then next kind of scenario is coincident line. What is coincident line? Is basically they are actually the same line. So if they are actually the same line, coincident line will have two properties. They must be parallel, and then confirm the whole line intersect another line. Okay, so how do I check whether lines are coincident or not? So very simple. Okay, remember coincident lines are parallel and they intersect. So let's handle parallel first. Look at these two vector equation of the line. Are they parallel? How do I know? Focus on the direction vector. Okay, focus on the direction vector of the line. Are they parallel? So observe that 2, 1, 1, 2 times 2, 1, 1 is 4, 2, 2. So L1 is parallel to L3. Okay, next, I need to check if this point 103 lies on this line. Okay, I need to check if 103 lies on this line. So I'm going to consider again. So consider 103 is equals to the line. Same thing, I can generate 3 equations. Okay, looking across horizontally, I generate 3 separate equations. And then from there, if you solve each one of them, you realize that mu is equals to minus half. So if mu equals minus half can satisfy all 3 equations, what it means is that 103 lies on this line. Make sense? So if 103 is lying on this line, and at the same time the two lines are parallel, L1 and L3 are actually the same line, or actually they are coincident lines. Okay, so important thing, remember, if they are coincident, the two lines are parallel and they surely have a common point. So the next item is we're talking about skew lines. Skew lines basically will mean two lines that are lying in different dimension. So if you look at this diagram, okay, just look at one side of the car versus look at above the windscreen. These are two lines. They are 100% not parallel for sure. But then will they intersect? They will not intersect, even though they are not parallel. So the key features of skew lines is that they are non-intersecting and non-parallel. Okay, so how do I check whether lines are skew or not skew? So first thing, check parallel or not parallel. How to check? Look at the direction vector. Okay, the direction vector will tell you for sure that they are not parallel because they are not vector of one another. Then how do I check they're intersecting or not intersecting? So same thing, check. Okay, can you equate the two equations together? So consider again equating the two equations together, and then same thing, generate 3 equations horizontally. Same thing, you have 2 unknowns but you have 3 equations. Use any 2 equations, okay, 1 and 2, to solve for your lambda and your mu. Thereafter, pump into the third equation and check. And this time round, you should realize that the left hand side of equation 3 and the right hand side of equation 3, under the condition of lambda equals to minus 2, do not satisfy one another. So you can conclude that the two lines do not intersect this way. So they don't intersect, they are not parallel. So final conclusion, they must be skew lines.